Section 5.6, Objective. I can add and subtract rational expressions. So remember with fractions, if you're going to add two fractions, for instance 1/2 plus 1/3, you need to have a common denominator. So the first thing we would do would be to multiply top and bottom here by 3 and top and bottom here by 2 to get 3/6 plus 2/6, which gives us 3 plus 2/6, or 5/6. So in order to add or subtract fractions, you need a common denominator. So for instance, if I had 1/5 minus 1/6, my first goal would be to get a common denominator. The common denominator would be 30, so I would multiply this top and bottom by 6 and this top and bottom by 5, which would give me 6/30 plus 5/30 equals 6 plus 5/30, or we would normally just write that as 11/30. So the rule is, if you have A over C plus B over C, the answer is just A plus B over C. And by the same token, if you have A over C minus B over C, the answer is just A minus B over C. So our goal is to get a common denominator. Well, it's exactly the same process with rational expressions, except for we're working with variables. So examples. Number 1, let's say I have 1/6a squared plus 1/3b squared minus 2/a times b. Well, my first goal would be to find a common denominator. So the common denominator, the least common multiple of 6a squared, 3b squared, and ab, the least common multiple is going to be 6a squared b squared. So my first goal is to get each denominator to look like that. So I would have to multiply the first rational expression by b squared over b squared. I would have to multiply the second rational expression by 2a squared, top and bottom by 2a squared. And the third rational expression, I would have to multiply top and bottom by 6ab. Then I would multiply, so I would get b squared over 6a squared b squared plus 2a squared over 6a squared b squared minus 12ab over 6a squared b squared. Then the next step is to write it all over the same denominator. So I would have b squared plus 2a squared minus 12ab all over 6a squared b squared. And then we probably would rewrite that. The proper order would be 2a squared minus 12ab plus b squared all over 6a squared b squared. And normally we would reduce, but we can see that there are no common factors there, so we can't reduce. Right? Example 2. Let's look at an easier one. Let's look at 5/6k minus 4/3k. Step number 1, determine the common denominator. The common denominator is going to be 6k. So I don't need to multiply the first rational by anything, but the second rational needs to be multiplied top and bottom by 2. So that would be 5/6k minus 8/6k, which would give us 5 minus 8/6k. k. Well, 5 minus 8 is negative 3. Okay, now in this case, we need to reduce, because 3 goes into 3 once, it goes into 6 twice. So we get negative 1 over 2k. So our final answer is negative 1 over 2k. So once you have done the addition or subtraction, remember to simplify as much as you can. Let's look at another example. So we have a minus 1 over a squared plus a plus 1 over 2a. Well, first thing I would do is, these are binomials, so I would put them in parentheses. The next thing, I would find the common denominator. Common denominator, the least common multiple of a squared and 2a is going to be 2a squared. Alright, so that means I need to multiply this one top and bottom by 2, and this one top and bottom by a. So I'm going to get 2 times a minus 1 all over 2a squared plus a times a plus 1 all over 2a squared. Now I have the same denominator, so I have 2 times a minus 1 plus a times a plus 1 all over 2a squared. Now I need to simplify the numerator. So first I'm going to distribute this 2. So it's going to give me 2a minus 2. I'm going to distribute this positive a, so it's going to be plus a squared plus a all over 2a squared. Then simplify the numerator, so I'm going to get a squared plus 3a, because I can combine this one and this one, minus 2 all over 2a squared. Then I want to see if I can reduce anything, and the top does not factor. This does not factor, so nothing's going to reduce, so we're done. Example 4. I have 1 over a squared b cubed minus 1 over 2a cubed b. Okay, step number 1, find the common denominator. So there's going to be a 2 in it, there's going to be an a cubed, and there's going to be a b cubed. Right? Because we find the least common multiple of a squared b cubed and 2a cubed b. So I'm going to multiply in the first rational. I need a 2. I need another a to make the a squared into an a cubed, and I have the b cubed. In the second rational, I have the 2, I have the a cubed, I have 1b, I need 2 more b's. So I'm going to multiply top and bottom by b squared. So I do the multiplication, I get 2a over 2a cubed b cubed minus b squared over 2a cubed b cubed, which is going to give me 2a minus b squared over 2a cubed b cubed. And the numerator does not factor at all, so that is our final answer. Okay, and number 5, I have 2 times y squared plus 1 plus 5 over y. Now remember, we have to treat that as a single number, so we put parentheses around it. And we need a common denominator, so I need a y, and I need a y squared plus 1. So I'm going to multiply the first rational by y, and the second one by y squared plus 1. So if I do the bottom, I must multiply the top. So now I do the multiplication. So I get 2y over y times y squared plus 1 plus 5 times y squared plus 1 all over y times y squared plus 1. Now I need to simplify the numerator. So that's 2y plus 5 times y squared plus 1 over y times y squared plus 1. Distribute the 5. Okay, so I distributed here and here, all over y times y squared plus 1. And normally we would write that as 5y squared plus 2y plus 5 all over y times y squared plus 1. And the top doesn't factor, so we're done at that point. Right, and let's do one more. So number 6. We have a over b minus a plus b over a minus b. Now we need the same denominator, and here's a little trick. Notice that when we put those in parentheses, we have the same variables, but they're opposite signs. So if I factor a negative out of this one, that's going to give me a over negative 1 times a minus b plus b over a minus b. And remember, with fractions, we can take a negative and put it in the numerator. So I have negative a over a minus b plus b over a minus b. And I have the same denominator, so I have negative a plus b over a minus b. But again, using the same trick, if I factor a negative out of the top here, it just switches the signs inside. And then this reduces with this, so this is equal to negative 1.